Hi everybody. Today we're going to be talking about extrema on an interval. And so we will look at how can we use calculus to find the absolute maximum and to find the absolute minimum of a function. Now, relative minimum and relative maximums are two things that we will get into a little bit later, but for today, we're just finding absolute maximums and absolute minimums. So first of all, you should know what an absolute maximum and an absolute minimum are. Absolute maximum also can be referred to as the global maximum, or even you might hear some people call it the maximum. And the maximum value of a function is the highest y value of a function. So on this graph, here would be the absolute highest point on the whole graph. And so I would say that the absolute maximum, or the apps max, is 2, and then it's at x equals 2. The absolute or the global minimum, also known as the minimum, is the lowest y value of the function. And here, the absolute lowest point on this interval happens right there. And so I would say that the absolute minimum is -1, and it happens at x equals 5. So when you're asked for the absolute maximum or the minimum, you'll get the y values. Now, we will be using calculus to identify the absolute maximum and minimums of functions. But first, let's talk about something called the extreme value theorem. The extreme value theorem says if a function is continuous, meaning there are no holes, gaps, asymptotes, so no, continuous on a closed interval, and closed interval means that the endpoints are solid. Okay, so those are the criteria for the extreme value theorem. Let's look at these graphs. So I have the extreme value theorem, and in order to apply it, the function has to be continuous and it has to be on a closed interval. So I can say that the extreme value theorem would not apply to this interval because of the endpoints are not closed. Same for this one and same for that one. The top graph, the extreme value theorem does apply because the endpoints are closed and the graph is nice and continuous. So same for the bottom one. So what happens if the criteria is met? Well, if a function is continuous on a closed interval with solid endpoints, then there must be an absolute maximum and an absolute minimum. Okay, so the extreme value theorem is proving that the absolute maximum and the absolute minimum must exist. So now let's talk about how we can do that. We're going to skip a little bit. There's 4 steps we're going to need to follow. How do I find the absolute extreme on a closed interval? Step number 1, you need to find something called a critical number for f of x. And so we'll spend a little bit of time on step 1. Find a critical number for f of x. Well, what's a critical number? A critical number is where the derivative is 0 or it does not exist. And if we look at that graphically, it would happen right here, because if there's a smooth curve and we see a peak or a valley, you can see that there would be a vertical tangent line. Or if there's a cusp or a point, sorry, this would be a horizontal tangent line. Going back, this is a horizontal tangent line. But if there's a cusp, the tangent line would be vertical. So critical numbers occur at x values where either the derivative equals 0 or it does not exist. So step 1 of how to find absolute extrema is to find the critical numbers. So let's go through and find some critical numbers here. So example 1. Here's the function. We have to find the absolute maximum, but the first thing we need to do is we need to find the critical numbers. And critical numbers happen where either f prime of x does not exist, or when f prime of x equals 0. So first of all, I need to find f prime of x. So I'll take the derivative of f. It would be negative 3x squared minus 6x plus 0. Now, f prime is a parabola because that 2 tells me that I have a quadratic function. And parabolas exist everywhere. There are no holes or gaps in the derivative. So I would say that f prime exists everywhere. So there are no places where on this function where the derivative would not exist. But now let's find out where the derivative would equal 0. So I'd take that derivative. I'm going to take this, and I'm going to set it equal to 0. So negative 3x squared minus 6x, I'm going to set it equal to 0. And then I'm going to solve for x. So I have negative 3x times x. I factor out a negative 3x, and that leaves me with x plus 2. If I set both of those factors equal to 0, I'll get that x equals 0 and x equals negative 2. Those are my critical numbers. Okay, so that's step 1. Find your critical numbers. Step 2. After you find your critical numbers, you're going to evaluate f, not f prime, f. So the original function at each critical number. Okay, I'm going to evaluate the original function at the critical numbers. So that means I'm going to take my original function and I'm going to evaluate it at each of those critical values. So I need to find f of 0 and I need to find f of negative 2. So f of 0 would be negative 0 cubed minus 3 times 0 squared plus 6, and I get 6. F of negative 2 would be negative 2 cubed minus 3 times negative 2 squared plus 6. So that would be, grab my calculator, negative 8 minus 12 plus 6, negative 14. Okay, I evaluated the original for the critical numbers. And I got these two. Got 6, and I got negative 14. Okay, step 3. Let's go. I'm going to evaluate, again, the original function, f of x, at the endpoints. And the endpoints are what are in those numbers in the bracket that you'll see in the problem. So in this problem, these are my endpoints right here. So then I'm going to substitute in negative 4, and I'm going to substitute in 2 into the original function. So f of negative 4 would be negative 4 cubed minus 3 times negative 4 squared plus 6. And that would be minus 3 times 16 plus 6. That doesn't sound right. 64 minus 3 times 16 plus 6, 22. And then f of 2 would be negative 2 cubed minus 3 times 2 squared plus 6. So that would be negative 8 minus 3 times 4 plus 6, negative 14. Pause real fast. Okay, so I checked my math on these. Let me edit. Okay, so f of negative 2 is not negative 14. F of negative 2 is positive 2. F of 2 is actually negative 14. All right, so I evaluated all 4 of those. All right, so my last step is the largest number is the absolute maximum, and the smallest is the absolute minimum. So then the smallest number would be negative 14. So negative 14 is my absolute minimum. And my largest number that I got was 22. So 22 is my absolute maximum. So that is how we can use calculus, critical numbers, derivatives to find absolute maximums and minimums of original function.